Okay, so now for our second amine, we're still starting from a halogenoalkane, but hopefully you've noticed that when we're forming our amine, this amine that we have produced has got one more carbon than our original one did. So we are extending the carbon chain. And as soon as we're extending the carbon chain, the first ion, really, the first species that you should think about is your cyanide ion. So you're going to go via a nitrile. So instead of just going directly with ammonia to get this, we need something with a carbon on it first. So we're going to add our cyanide, CN minus. I'm going to put the minus on the carbon and the lone pair on the carbon, just so that, we're drawing everything correctly. And we end up with our nitrile. I'm going to draw the triple bond here just because that's hopefully going to help us later on. In terms of the reagents and the conditions, this is not the reagent, right? This is just the ion that's involved in the nucleophilic substitution. The reagent that we're using is potassium cyanide, and your conditions that's going to be in, I'll put it under here, in aqueous ethanol. So that means that we've got ethanol and water, and also heat under reflux. I have to admit, these conditions, I always forget these, but because I always forget them, now I remember them. I'm like, oh, which are the ones that I always forget? Oh, it's the aqueous ethanol and heat under reflux for nucleophilic substitution with potassium cyanide. So now we've got our nitrile, and we're trying to get from our nitrile to our amine. Again, hopefully you've spotted the only difference between our nitrile and our amine is that we've got some extra hydrogens in our final product. So we have added, of course, 2 hydrogens to the nitrogen, but we've also added 2 hydrogens to the carbon. So that's this carbon here. So because this is reduction, addition of hydrogen, we can represent this in our equation as plus H plus, not H plus, plus H in square brackets. And because we are adding 4 hydrogens, we can put a 4 in front of our H in square brackets. In terms of what the actual reagents and conditions are, there are 2 that you could possibly learn. So learn and remember your favorite one, but make sure that you can spot both of them because they could both be given in the exam itself. So we could use LiAlH4 in dry ether, or we could use just hydrogen with a nickel or a palladium or a platinum catalyst. And that's it, right? Extend the carbon chain, go through a nitrile. The last one, and again, the difference between specifically, well, this amine rather, and the other 2 is that this one has got a benzene ring. So this is an aromatic amine. Specifically, this is phenylamine. And aromatic amines come from nitrobenzene. Now, how to form nitrobenzene, that is a video unto itself. So now we're going to start from the place where the nitro group is already on there. And then how do we get from here to here? Well, again, hopefully you can spot the only difference is instead of these 2 O's, we've got 2 H's instead. So this once again has to be reduction. We're adding hydrogen. So we can represent that with our reducing agent, so H in square brackets. To balance this, it's not quite as straightforward as the one before where we just add the hydrogens that we've added, and that's because these oxygens are falling off, and when they fall off, they are going to give us water molecules. And specifically, we're going to get 2 water molecules because there are 2 oxygens here. So now when we think about the difference in hydrogens, we have added 1, 2 hydrogens here plus 4 hydrogens there, which gives us 6 overall. Now, for AQA, A-level chemistry, we can just do that, right? One ridiculously long arrow. It doesn't have to be that long. And the reducing agent that we use is not one that we see anywhere else in the course. It is tin with HCl, okay, as our reducing agent. Something that is not necessarily strictly on the spec, but is worth spotting in case, they weave it into like a longer synthesis, like practical question, is because we're forming an amine, which we know is basic because of the lone pair on that nitrogen, and we're carrying this out in the presence of an acid, we're not actually going to get the amine straight away, right? Instead, we are going to get our ammonium salt where that amine group is protonated, right? So like that from the HCl. So to actually get our final amine, we would need to add sodium hydroxide before aqueous, right? We would need to add sodium hydroxide to actually get our final product. Again, that bit you can take with a pinch of salt. Sorry, I really enjoyed that. Because ultimately we go like here first and then here, but for all intents and purposes, you can just consider this arrow and just using your tin and HCl to go straight to your final product. And that is it. 3 different methods depending on what you're starting from and what you are going to. For more A-level chemistry practice, make sure that you have subscribed. Make sure you like this video, comment any questions or whatever you want to comment, right? Really. And I will see you in the next one.